I'm not 100% sure I understand your question. So I'm going to try to answer best I can. It might take a little longer than it should. So this is the problem number 15, and the question is, does force of gravity matter? And the answer is absolutely 100%. The question doesn't ask that, though. The question asks whether or not the force normal is equal to the force of gravity, and the force perpendicular is equal to the force of gravity. So I'm going to try to answer that question. Again, I'm not sure where you're at, and so if something doesn't make sense, you just let me know. Send me another email or come by tomorrow. That'll work too. Or today. We should be home by 5. Okay, so real quickly, the way you do these problems is you have a block on an inclined plane. There are 3 real forces on it. You have force of gravity pulling straight down. Okay. And then you have force of friction. Those two are, generally speaking, the ones that most people remember. Force of friction. I'm right around my fingers. That's not great. Okay. And then the third force, which people tend to forget, is force normal, which goes this way. Now, again, force normal tries to stop the block from going into the inclined plane. Now, the problem with all of this is that it doesn't give me a really good way to figure out how fast this thing would accelerate down the inclined plane. And the reason for that is we know gravity's making it go down the inclined plane, but it's pulling straight down and the block's not going straight down. Okay, and so we use that idea that you hopefully learned for another item or two, which is components. And so what we're going to do is we take the force of gravity, say, well, let's break it into the board direction. Whoops, that's not good. Let's try this again. Into the board direction, and then along the board direction. And so this is what they call force parallel and force perpendicular. Okay, and that's what I think that's the terminology your thing uses. Let me quickly check that. Force perpendicular, force parallel, it does. And I drew my thing backwards, so that's a problem. But the idea still holds, right? So this force down here, this component represents essentially the force down the inclined plane, and this represents what's canceled out by the force normal. In other words, how hard the block is pushing in. The block is pushing into the inclined plane. Let me choose to add another color. The block is absolutely pushing this way, but the board says, no, I'm going to send you that way. Okay, you can't go through me, which is what causes it to slide down the inclined plane. The short answer is this component represents the same thing as force normal, and this component right here represents the same thing as the force of gravity that's left over for going down the inclined plane. Right? Okay, with all that in mind, let's get to your question. The question was, why does gravity not matter? And gravity absolutely does matter. But force perpendicular is this is force of gravity down here. This is force perpendicular. And force perpendicular is just a component of the actual gravity. And so it's just part of the force of gravity. So because of that, it can't be equal on an inclined plane. It would be equal if you had a block sitting on the ground on a horizontal surface. The force of gravity pushes down, the force normal keeps it from sinking into the ground, and so those have to be equal because it's not moving. But in this case, because on an inclined plane, this component of the force, which is not all of the force, cannot be as big as the force of gravity. Okay? The same thing, by the way, goes for force normal, which has to be equal to the force perpendicular. Why? Because this represents how hard I'm pushing into the force perpendicular represents how hard I'm pushing into the inclined plane. Force normal is how hard I'm pushing out. And those have to be equal, otherwise the thing sinks into the plane. Okay? And so the rest of these, running through them quickly, that hopefully answered your question. If it did not, again, send me a note, whatever. Does force normal equal force of friction? No, can't, because force normal is this direction. And by the way, remember, force of friction is equal to mu force normal. As long as mu is not 0, not 1, force normal can't equal force of friction. right? In this case, it certainly wouldn't. Force net equals force parallel. The force net is 0. Force parallel is this component down here, so therefore those can't be equal to each other as long as it's on an inclined plane. Force perpendicular is equal to force normal. Force perpendicular is this one. It's essentially this piece. And then, actually, let's use a different color because we use the same color over and over again. Here we go. Force perpendicular is how hard you push into the inclined plane. If you don't sink into the inclined plane, then force normal has to be equal to it in the opposite direction. Okay? Force normal equals, force perpendicular equals gravity. Again, that's a component of gravity, so it can't be equal to the whole thing. This cannot be equal to that. There's no way because it's just a component. Force normal is also equal to force perpendicular, so those two still can't be equal to each other. Force parallel is equal to force of friction. Force parallel is this, how hard it's being pulled down the inclined plane, which is this component right here. And that's, if it's not accelerating, then the force parallel and force friction have to be equal to each other. Otherwise, it would start to accelerate one way or the other. Okay? And then last but not least, force of friction, mu force normal. That is actually the definition of force of friction, so therefore that one has to be true. I hope this answered your question. If it did not, just come by today after school. We should be home about 5. And I can run you through this because I may not have addressed your question very well.